So good afternoon, everybody. This is the last class of the course. It's on consciousness. This consciousness from a neuroscience point of view. So you can discuss consciousness from a philosophical point of view also, but we'll be focusing on how can you address this problem or this topic from neuroscience point of view. This photograph here shown is from a movie called Looney Tunes, Back in Action. It's actually based on a comic strip. I don't know if any of you have read this comic strip. Basically, this lady is saying, we do have the resources to reconstitute the body. The mind, though, will remain a gooey mess. So basically, they convert, I think, this Bugs Bunny or a duck, Daffy the duck. They convert it into some kind of a fluid and pack it in a test tube. And those two dots that you can see are the eyes of that character. It's just supposed to be funny. So the question of mind is quite difficult to discuss in science. Right, brain, you can do lots of things. You can measure things all the way from single molecule to large scale whole brain imaging and all that. But when it comes to consciousness, things suddenly become very difficult because it's even hard to talk about how to talk about this topic. So let us look at some ideas about what people have been saying about consciousness. So what we have discussed so far in this course and what you generally see in neuroscience textbooks is about how brain works, right? And what that, so we have, it's possible to look at things from single neuron recordings to gene knockout studies, and also you can, in contemporary neuroscience, you can get data of, at multiple scales, right? So, right, and data of all sorts of kinds. So a lot of data is available about various systems in the brain, various spatial scales, and so on. So neuroscience explains, what happens to sensory information when you present a stimulus to the brain, and how does the signal climb to what pathways, and where does it reach ultimately, and what kind of neurons will respond. All sorts of those kinds of questions you can answer very well. Or when you are afraid, again, what are the pathways that process fear, and what are the cortical pathways, what are subcortical pathways, and so on and so forth. So you can look at that. Or simple sensory processing, you look at a picture and then how is it processed, you can know that. But more interestingly, you can recognize objects out there, but when it comes to recognizing, identifying yourself, the first object that you will ever encounter, which is yourself, right? How does brain do that? How does brain get the sense of me, sense of I, right? This what is called self-consciousness. So when it comes these kinds of questions of subjective nature, things become very difficult. So the big mystery for science, is me. How do you deal with me? Because this is a Popeye, again, is a comic strip character that is saying I am what I am, and that's all that I am. So the problem, just to give an idea of why you bump into fundamental problems when dealing with consciousness or even sensory awareness or sensory perceptions. Let's take this example. So you're looking at this blue oval or blue ellipse in this case. Everybody will agree that this is blue, right? But is it that simple? I mean, is the agreement so universal that everybody, anybody who knows some basic English words will agree that this is blue? It's not that simple. So there was a big controversy in social media a few years ago, I think in 2015. So where they showed this dress and asked people, what color is this dress? So some people thought, right, that it is white and gold, especially if you look at the leftmost version of the image, it looked like light and gold. And if you look at the middle one or even the rightmost one, it looks more like what was thought to be white becomes bluish, and what was thought to be gold becomes either black or deep brown. Okay, so why does it happen? Right, people, there's so much of controversy, people couldn't agree. Because what happens is our perception of color depends a lot on the context, right? So in this case, it's a very simple case where there is blue and there is white background. But if a color is surrounded by a bunch of other colors, then our perception of that color is judged by the neighborhood, the context. And that is because basically brain tries to come up with a color perception which is independent of the context. And that is necessary because our color perceptions are, in a sense, colored by your background lighting. Because the background lighting, if you look at the sunlight, changes with the time of the day. Early in the morning, it has a kind of orangish tint. and midday it is white and slightly has a bluish tint, and again evening again it has orange tint. So when you perceive color, should be independent of these lighting conditions in the ambient environment. So in the process, it makes mistakes. By in the process of trying to cancel out the influence of context, right? It creates a kind of a variability, and that can depend on from person to person, because it's a very complex process that occurs in the brain in coming up with this, in handling this problem of color constancy. So basically, whenever you talk about perception, right, or consciousness or awareness, it's a private thing. It's something that you, whatever that means, that there is somebody called you, there's somebody called I, right, and it's not just this body. The body is something that is part of the objective world, right? You can measure things, you can look at things with a microscope, you can probe the body, and it's all, doesn't matter whose body it is, it's a part of the objective world, right? Can be measured in the same way by everybody. But all of us have a subjective world, subjective sides to ourselves, and that what we feel, what we think is is known only to us. So there's something private about consciousness. So even this privacy, it's not a there is no fixed hard line, because these days the technology has improved so much that you can look at the brain's activity through EEG, fMRI, and kind of read what you are thinking, in some conditional simplified context. So even what we thought is strictly private is not anymore strictly private. The machine can read it, okay, and it can even become worse in the future. But definitely there's something called, at the core of it, something called I, which is totally private, right? That's something the other person will not know. And this fundamentally private aspect of consciousness is what poses deep problems to conscious research, because science, modern science by its very nature, is objective, is empirical, right? You have to be able to, whenever you define any concept or a quantity, it should be such that anybody can observe it, measure it, and even quantify it, express it in numbers. This is a basic requirement of any scientific topic or a quantity. So because of that test of right that you apply to any scientific object, it becomes quite tricky to measure or deal with consciousness. So the moment you talk about consciousness, the situation becomes sort of like this picture, the sketch by the Dutch painter, MC Escher. He called this painting relativity. You see that different people are climbing on different staircases, and there's no real vertical, right? Each person thinks that he or she is right following the correct vertical, and climbing stairs are up or down, and but there is no real vertical. Everything is relative. So that's the kind of world, in fact, that we live in, because the true subject is known only to us and others don't know. What is actually mysterious is, if that is the case, then how come we all agree on at least certain things? We may not agree on many things, but we agree on certain things. That's why we're able to. So that is, we agree that we all live in a certain world which is three-dimensional. There is time, there is space. We live on a planet called Earth. There are certain laws of physics which are common to everybody, right? So we agree on certain things, it's not everything. So even that is quite surprising. That is at the core of it, this subject who is completely private. How come we agree on certain things? That's a very hard question. We don't know the answer. So now the question is, let us come to brain, right? What about brain? Can we say brain is conscious? All right. Yeah, I mean, we think we are conscious, but even here there are gradations of consciousness, and which can be quantified, in various ways. Like for example, a normal waking state of a healthy adult, that's a fully full consciousness. Or a dead human, completely no consciousness. I guess we expect that there won't be any consciousness. Or human in coma is better than a dead human, like a dead body, but it's still not quite conscious. Or human in deep sleep, you would think will be less conscious. And human in dream state, you would expect to be slightly higher, have higher consciousness. Light grogginess, you just got up and you start still trying to figure out, is it morning or is it evening? Where am I? Just at the moment when you woke up. That is, you're conscious, but you're better than dream sleep, hopefully, but it's not quite waking. And then fully waking state. So there are all the gradations. And a lot of these differences can be seen in EEG. If you take data from your scalp, the electroencephalogram data, by extracting certain chaos parameters, you can differentiate a lot of states of consciousness. For example, in waking, these chaos parameters are highest, and slightly lower in dream state, and even lower in deep sleep. Right? And even in case of seizure, like when somebody is undergoing a seizure, at that moment the person is not conscious. In fact, the brain dynamics, that is, the activity of EEG will be very high in terms of amplitude, but the activity will be less complex, right, compared to the brain dynamics in a waking state. So therefore, the person is not conscious. So consciousness is not just about the intensity or the level of activity of the brain, but it refers more to the complexity of the activity of the brain. It's not just amplitude, but it's a complex information complex. So there's a lot of data and a lot of theories on that. I'll skip that. I won't be covering all that in this class. So what about primates? Like the whole monkey. Monkey is a loose common term, but primate is a more technical term. Are they conscious? Because they are just our forefathers. So can we also have to give them the attribute of consciousness? So these are difficult questions, very controversial, and people haven't come to an agreement. So if you look at now history of consciousness, one of the earliest, especially in the Western tradition, there is this philosopher, a mathematician called René Descartes, French chap, and his disciples. So they had some ideas about mind and body. So according to Descartes, mind is a substance which has no spatial extension. So mind is beyond space and space, right? It is not, you're not tied to space, and it's somehow capable of the power of thought, because that's mind, right? Mind has thoughts. Then there is thing called body, which is a piece of matter, and it has spatial extension. It by itself cannot think. Okay, so now how do you bring the two together, right? So they're basically two different substances. Mind is different from body by its very nature, but then they come together in a living human being, right? They interact, and how do they interact? How do they interact? Through apparently through this gland called pineal gland, which is located inside the brain. But then pineal gland is just another piece of matter. What is so special about it? Because body by itself is not capable of thoughts, right? And pineal gland is just a piece of the body. So how come pineal gland is enabling interaction between mind and body? What is special about it? Well, it is where this guy's really bomb. They say that it is presided over by God, and God kind of makes sure that the interaction between mind and body goes okay through the agency of the pineal gland, which is total rubbish. The moment you bring in God, you're bombing big time, right? So anyway, these are the kinds of ideas you see that the problem is up to some point you can make sense. Beyond some point, you go into very fundamental problem. That's why you start making random assumptions. Now William James, so Descartes is much several centuries ago, I guess 17th century or something like that. William James is an American psychologist from late 19th century. He's written several series of volumes on psychology. So his proposal is that consciousness is a selection agency, which is quite a beautiful suggestion. It says that it selects from among several thoughts, several alternative thoughts. Right? The brain acts as a whole in producing conscious thoughts, which is quite true even from modern point of view, where you can see the brain's activity, brain dynamics, using tools like fMRI, high density EEG, and all that. So whenever your conscious brain acts like a whole, it's not. So even when you are looking at a visual information, and if you are conscious of it, the activity is not confined to the visual cortex. It embraces the whole brain, especially the frontal area, prefrontal areas. So a big part of the brain gets active whenever you are conscious of anything. All right. So that's what he says. And the role of consciousness is to select from among those multiple thoughts. But once you enter 20th century, people start taking more extreme positions, because things like consciousness, people were not very comfortable, right, in 20th century. The 20th century is the century where there is rise of physics, right? Physics has gone to real peaks, and so it's very hard to talk about things like consciousness from a physics point of view. And 20th century, the insistence is that everything should become part of physics, should come under the kind of physics-based explanation, and that becomes very hard when it comes to topics like consciousness. So therefore, people started taking a very hard positions about consciousness. And J.B. Watson, right, who was father of what is called behaviorism. Now he said, all these, for example, people describe animals' behavior. They would tell all sorts of stories that animal is now. Why is it eating? Because it's motivated to eat. Why is it not eating? Because it has no motivation to eat, right? And why is it not doing something? It is afraid of doing something. So all sorts of. What are these terms? What is motivation? What is drive? What is instinct? So people just throw concepts and for which there is no simple physical counterpart. There's nothing in the brain that I can just measure and say, "Oh, this is instinct. This is fear. This is a drive." Right. So this behaviorist took a hard position, saying that if you cannot observe it and quantify it, then don't talk about it, don't mention it, don't use such terms, right? Because that's not science. So it's a very rigorous position, but obviously that makes it so much harder to talk about consciousness. So forget about psychological states. They won't even entertain mention of brain states, because this whole behaviorist revolution happened in the early 20th century, and at that time we didn't know much about brain dynamics and neural recordings. All that came much later. So this was the kind of position in behaviorism, where focus was on behavior, what you can see from outside, and don't mention anything happening inside the brain because it's like a black box. That was the approach. In the second half of 20th century, things went on in a different direction. At least a section of psychology went like that. The cognitive revolution took place in the second half, and where because of the rise of the computer, I think I mentioned some of these ideas in the discussion on emotions. So people wanted to explain all brain function in terms of like an algorithm, like steps in a long procedure, right? So some information comes into the brain. It is first processed by module one, then module one passes it to module two, and module two does some more number crunching, and so on and so forth. So this is like a bucket brigade. Brain works on input coming from the world like a bucket brigade. So that was a kind of understanding. Now, artificial intelligence also kind of emerged around 60s, last century, and so the assumption is that intelligence is basically mechanical. Intelligence is an outcome or a result of certain right body parts working together or certain brain parts working together in certain fashion. It's basically physical. It's mechanical. So there are certain rules underlying intelligent behavior, and if you can crack what those rules are, right, and implement them through whatever means, you can have moving wheels, you can have electronic circuits, you can have flowing water. Doesn't matter what it is, right? If you can implement those rules in some kind of a physical process, you can produce a machine whose behavior will look intelligent. That's all. Intelligence is a question of a bunch of rules. So if you look at all these things, behaviorism and cognitive science and AI, they don't explain consciousness because they seem to somehow reduce it to some kind of physical process, a sequence of steps and things like that. So therefore, something kind of gets something evaporates in the process. And even when it comes to questions like what is free will, the 20th century position is that there's no such thing as free will, because if everything that all that there is in the brain is a bunch of physical processes, and physical processes are defined by or controlled by certain physics-based equations, which are deterministic. There's no question of free will in a physics-based process, right? A material process. So whatever you think, that as free will, right, in your mind, it's just an illusion. You're just hallucinating, right? So this is the picture here is Marvin Minsky. He never said I'm a zombie, but I mean, by the assumption, by the position he has taken, he's in one of the AI forefathers of AI. But by the position he has taken, he's almost like as if he's declaring he's a zombie. So what we feel about ourselves are delusions. That's what they're saying. But do you really buy that? I mean, do you really feel that you're actually a zombie and your feelings are non-existent, your thoughts are non-existent, it's all illusion? That doesn't make any sense beyond a point. But the problem is this materialist position, a strong materialist position which people have taken in the last century. Things are yielding a lot right now. But this was a kind of drift of thought throughout the last century. And people were pushed to take absurd positions or come to absurd conclusions. So anyway, the debate is still on, but people don't take these kinds of positions now as more willing to look at the questions of consciousness using some very slick experiments. So some interesting experiments have been performed, which really opened our eyes to the nature of consciousness. So you can trace these developments back to Wilder Penfield's brain simulation experiments, where you know that he has stimulated brain electrically and at various parts, and people reported experiences. So when you were stimulating occipital lobe, they were reporting something called phosphenes. So they would see flashes of light. Obviously, there's no real light outside, but they would still see light. Or if you simulate the temporal lobe, they would recall songs that they have heard long ago. Or if you stimulate the somatosensory cortex, they'll feel that somebody is touching them, on the body, and things like that. Right, and not only that, you don't even have to touch the brain, right, and poke it with electrodes and pass currents. Even if you shoot magnetic pulses at the brain, at the cortex, through something called transcranial magnetic stimulation, or TMS, right, depending upon where you shoot these pulses, you can produce experiences. Shoot the pulses at occipital lobe, you will see flashes of light, and so on and so forth, right? Even if you can even do things like you are performing some task, some motor task, and you shoot these pulses at a critical part in your motor cortex, like one of the higher motor cortical areas, like pre-SMA, SMA, somewhere there. It can make you stop, in your output, stop your movement, right? So you can interfere with brain dynamics, interfere with behavior, interfere with your thoughts, right? Even without touching you, simply by shooting EM pulses at you. So the thing is, some of these experiments basically tell you that it's not just what happens, in terms of the stimuli given to the brain. Something that's happening intrinsically in the brain, that's what is creating experience. So we should look for answers there if you want to understand consciousness. So there is only a weak link between the stimuli that come from the world and the experiences that you have, right? Your brain or your subjective self is not a helpless victim of stimuli coming from the brain. The stimuli can come, the same stimuli can come, but people can have different experiences because there is something intrinsically free or right, slightly indeterminate about your subjective experiences. Let us look at some examples. So in this case, I know you all can see this black and white picture, right? You can make this experiment later on at your homes. You look at this picture, just stare at it for about 20 seconds. And after that, you shift your gaze to some white background, right? And look at the white background for a little while. And suddenly you see that the picture that you see, you'll continue to see a ghost of a picture, like a ghostly image. And can anybody tell me what that ghostly image will be? Hello? Hello, anybody? It happens to be a picture of Jesus Christ. Okay, you can test it for yourself and find out. And you also should be able to give an explanation as to why it is happening. So basically, this is called an after image. That is, you might have had this experience even normally when you look at a strong glare of light. For example, if you look at a car headlights for a few seconds and turn your gaze away, you will still see kind of a faint light in your field of view, even though the car has moved away, right? And that's because the light stimulus, which is a very strong stimulus, has left some lingering activity in the brain, and that's what you're experiencing. Again, all this shows that what you experience is not actually world out there, but your brain's dynamics. So through artificial means, by implanting chips or whatever, by wiring up brain in certain fashion, if I can tamper with brain dynamics, brain's activities, I can tamper with experience. That raises really fundamental problems, because then what is it that we call this world? Is the world really out there? Right? So it raises really fundamental questions if you think about it deeply. Another after image experience goes like this. So you see this picture where there's a green bird and a red bird. So stare at the green bird for about 20 seconds and then shift your gaze to the cage. Cage is empty, but when you shift your gaze, what happens is you'll see a ghostly version of the green bird now sitting inside the cage. And the ghostly version will be shocked to find that it changes its color. It won't be green. So similarly, the red bird, also you focus on it for 20 seconds and shift your gaze to the cage. You will find a bird of the same shape, because two birds have slightly different shapes. You can notice that. The ghostly bird that you will see will have the same shape as the original, right? But the color would have flipped to something else. So what color does it flip to? The answer is here. So you see that there's these complementary colors, and we talked about them when we discussed the colors of emotions, right? So the complementary color of red is cyan, and for green it is magenta. So here what you will see, if you the ghostly bird of green will look like um, magenta in color, and the ghostly bird of red will look cyan in color. So why is that? Basically, some kind of inversion is taking place in the afterimage. So even here, this picture is actually a negative image of Jesus Christ image. So when you look at it, look at a white background, the afterimage flips, the negative becomes positive, and that's what you see in the afterimage. So these examples show that you can have an experience without any stimulus, right? Stimulus is just, it's all there inside your brain. The brain does a lot of things by itself to manipulate your experience. That's what it is saying. Either you manipulate it by external devices, by shooting energy pulses at the brain and things like that. Our brain does manipulation, in very funny ways by itself, and so which raises serious problems about what is the role of you in this whole thing. So let's come to that in a minute. So you might have all have heard of this something called blind spot. So that in this experiment, for example, if you close your left eye and fixate on the star on the left, right, with your right eye, and then start from a distance and closely approach the monitor, right, and keep staring at the star with your right eye, and you will see that the black dot is somewhere to the side on your peripheries. But as you approach the star closer and closer from a distance, you will find that at a critical distance, exactly at a critical distance, this black dot disappears completely. You can't see. Okay, and that is because at a certain critical distance, the black dot's retinal image would have fallen on a part of the retina where there are no photoreceptors. This is the part of the retina where the fibers from the retinal ganglion cells like dig through the back wall of the retina of the eyeball and go to the brain, right? So therefore, at that point, you cannot have any photoreceptors because there's a little hole there. So that's called a blind spot. We have one blind spot in each eye, but normally you don't notice a kind of a right hole sitting in each of the eyes. That's because where one eye sees a hole, the other eye sees some picture, something, some visual stimulus. So brain fills up, right, makes up for these two little deficits and creates a whole image. So you don't see the blind spot. But if you do special experiments with a single eye, then you see these kinds of blind spots. So blind spot can be a really a source of interesting experiments about how brain concocts stimuli where there is some missing information. Right. For example, in this picture, you again close your left eye, focus your right eye on the plus sign on the left side, and keep moving close to the image until a point where the black dot on the right side disappears. And you will be shocked to see that when the black dot disappears, because the black dot is now fallen on the blind spot, right, of the right eye. What you would expect is some kind of a gray haze because there's nothing, no information coming to that part of the retina. So you should see some kind of a gray colorless haze or a featureless haze. But what you'll actually find is the black dot looking green. So the surrounding green around the black dot simply moves in and fills up that black dot and it all looks green. Okay, so that means that this information is something that brain made up because brain believes in some kind of interpolation is a respectable word, or to put it more derogatorily, it believes in bluffing. Wherever it doesn't have the information, it somehow interpolates and starts, it just bluffs. It makes up some explanation. So creates some construct. just to fill up that vacuum of information. So these kinds of the blind spot has been extensively studied by V.S. Ramchandran and his colleague Richard Gregory. This kind of filling in happens dynamically and happens in many modalities. So we have seen filling in color. These people show filling in of motion, and then when you have motion and color and form, then filling in happens at different rates in different modalities. Lots of fancy experiments have been done using this phenomenon of blind spot. Even in cases where people suffer from what is called a scotoma, that is a small damage to the visual cortex, and because of that, they see like sometimes a gray kind of a dark dot where there's missing information. If the scotoma is small, you can sometimes see the filling effects, right? If it is very big, then it won't be able to fill. It fails to fill. Another phenomenon called blindsight. I think I mentioned Burns before. These people are clinically blind, but they can show visually dependent behavior, or behavior which requires some kind of a visual processing. So there again, you see that there is a conflict between motor function and consciousness. There is no consciousness. There is no sensory awareness of vision, but there is performance which depends on visual information. So you can see that these two are different entities altogether, different aspects of the brain function. So why does it occur? So like I said, information first comes to the thalamus, right, to the reticular nucleus in thalamus, and from there it goes to superior colliculus, right, which will control your eye, controls eye movements, and it also goes to higher cortical areas directly because thalamus projects to most parts of the cortex. So you can think of, and it also projects to the midbrain, and then from below that to the spinal cord. So you can see that there it is possible to conceive of a subcortical pathway, a sensory motor pathway, which is subcortical, right? So therefore, in principle, you can think of as some kind of sensory motor response that is conducted completely in a subcortical fashion. So that is the case, then you won't be informed. Your conscious self, which is more confined to the cortex, you don't know about it, but brain produces a response. So something like that must be happening in case of blind spot. So another interesting phenomenon where there's a mismatch between the stimulus and the experience. Because in all these cases, that's what we are seeing. There is a mismatch between stimulus and experience, right? And another one is binocular vision. So what is binocular vision? So when you're looking at the world with your two eyes, each eye or each retina, right, creates a different retinal image of the world because the two eyes look at the world from slightly different vantage points. So to the extent the two retinal images are also slightly different. So these two images are sent to the back of the brain. And in the brain, these images are fused and brain constructs a single unitary three-dimensional percept of the world. Okay, so these two retinal images are different, but not that different. So if you look at this simple schematic, right, there is actually a bunch of these pins that you play in a bowling game. So you see the same pins in both eyes, but from a slightly different angle, some slightly different viewpoint. But essentially, the two images are quite similar. But what happens if you artificially project very different images into the two eyes? So, for example, you can there's something called a stereoscope, right, where you wear this kind of a little device on your eyes, and so there is a little you can project an image on each eye, and so each eye you can create situations so that each eye sees very different images. So in one of these experiments, people showed like a red circle on to the left eye and blue circle to the right eye, and the circle had stripes. So there is let's say 135 degrees stripes to the left eye and 45 degrees stripes to the right eye. So the two stimuli are quite different, projected simultaneously to the two eyes. So now, what do the subjects see, right? Do they see some kind of an overlap version of the two images? Well, the answer is no. the subject saw only red circle and with a kind of backward 135 degree stripes for some time. After some time, suddenly the percept changed. Subject saw only blue circle. After some time, again only red circle. After some time, only blue circle. And also the exact duration for which they saw the red percept or the blue percept also varied a little bit. It's not a periodic oscillation between the two percepts. They kept flipping between these two because it as though brain couldn't make up its mind as to what it is looking at. Is it blue or is it red? What the hell is it? So it kept, it was ambiguous. It kept flipping between these two percepts. And you can even see that brain is doing this kind of a seesawing between the two percepts when you by analyzing the fMRI active, brain dynamics from fMRI recordings, right? And similar experiments have been confirmed even in case of monkeys. This kind of oscillation between percepts can be seen even in case of other optical illusions. I'm not covering them here. So similarly, there are similar interesting phenomena even in case of touch. So let us define what is called proprioception. So touch has two aspects to it. One is what information that you get from the skin. Especially your fingertips have very rich in mechanoreceptors, certain touch receptors. That's why if you want to probe something, you first touch it with your fingertips. Because there's a lot of information coming from there, right? The other kind of touch or somatosensory information comes from your joint angles or joints. So in the joints and in your muscles, there are sensors. So for example, in the muscles, there are sensors which send to your brain information about the muscle length, muscle tension, and muscle velocity. That means the muscle is changing its length. What is the rate of change of that length? X dot. All right. So X dot, and tension T. All these three informations are sent from the muscles to the brain. And similarly, within the joints, there are sensors which can sense the joint angle. So the muscle information and the joint information together can give to the brain an idea of the spatial configuration of the brain in the 3D world, in 3D space. So something like that is obviously necessary if you want to dance, for example. So if you look at the dancer, the ballet dancer in the bottom figure. So for her to take on some body shape like that, right? She must be processing her proprioceptive information in a very complex fashion. So proprioception means position sense. So it is possible, right? So normally you would think that the touch sense or proprioception sense is totally different from vision. But it is possible through technology to mix up the two and even substitute one for the other. Some of these experiments were done by, I think, Brazilian or Argentinian, I forgot, Paul Baquirita, a scientist from either Brazil or Argentina, I don't remember. So he showed how you can convert optical image into a tactile image. So basically, this is for blind people. Developed as a solution for blind people. So they take the camera output, and then it's a very low resolution image that you get from the camera. And for each pixel, you correspond to that, you feed it into some kind of a vibrator, right? And you take an array of vibrators and strap it on to the abdomen of the subject, right? So if you see a flash of light in the top right corner of the image, then you see like a buzzing sensation in the top right corner of your somewhere in the on your stomach or something like that. So like that, your optical image is converted into some kind of a vibratory image, right? Image of tactile sensation. So resolution was low, but people were able to kind of get an idea of what they were looking at, especially they can recognize simple patterns. Like in this display in the bottom, they were shown a simple intersection of two lines, and they can make out something like that by simply feeling on what they're feeling on the tummy. And initially, it felt like a tactile sensation, but with practice, with great familiarity, it almost seemed like a vision to these people. Right? It's a different kind of vision, but it seemed like vision. So based on that, this writer or philosopher Daniel Dennett, who's written a very influential book called Consciousness Explained, right, by Daniel Dennett. He says that tactile vision may be actually the same thing felt by blindsight patients. So blindsight people also, they feel something. They're not sure that it doesn't feel like vision, so they say they're blind, but they feel something, so that's why they're able to perform some activity which is dependent on vision. So the awareness is there, it is weak. So therefore, they are not able to clearly pinpoint and say whether that feeling is visual or tactile. There's something that is so weak that they're not able to classify it as vision or tactile. Right, and so what he suggests here is maybe there is nothing like pure vision or pure touch. There's just one awareness, and when you vary some intensity of it, it is experienced as different forms of sensory experience. But point is that's not very convincing, because if there is some awareness, and if I just very increase the intensity, into which modality does it get transformed? Will it be vision or touch? How do you decide? So it cannot be just a question of intensity. There's something else going on. But I must say, to this date, we still don't have a good theory of even sensory perception, right? But because in the brain, if you look at the three primary sensory cortices, uh, vision and sound and audition and touch, they're all cortical areas. I mean, the cell types are very similar, right? But how come the activity in each part is felt very differently? The sensory experience created is quite different, whereas the cell types and the anatomical structure and underlying substrates are very similar. So what is it that is creating a difference in terms of the sensory awareness, sensory modality? So we still don't know that. Okay, so let us move on to the next part of this class, this topic. And so what are neural substrates of consciousness? So first thing is, people found that when you present an object to the brain, and when we recognize that it's an object, neurons that respond to different parts of the object. Let's say you're presenting a bar, like a bar which has some orientation and it's moving. This experiment was done on earliest experiments were done on cats, on cat visual cortex by Gray and Singer. So when you show a moving bar to the cat, different neurons respond to that same moving bar, different parts of that bar, and all these neurons which respond to the same bar fire in very high synchrony. Right, so the way these neurons tell each other that they respond to the same object is by firing in synchrony. And that synchrony happens to happen in a specific frequency band, which is gamma frequencies. And gamma frequency can be anywhere between 30 hertz to 200 hertz. Okay, so that's 30, even high gamma is even beyond 100. So this picture shows gamma in the range of 30 to 100, but can even go beyond that. So this kind of a synchrony in high frequency bands, which is but specifically very often in the gamma band, is thought to be like a very important underlying marker for consciousness or sensory awareness. And even in disease conditions like schizophrenia, Parkinson's, this kind of a synchrony in the gamma frequency band is found to be effective. And when it comes to subjective experience, especially subjective aspects of time or subjective perceptions of time, right? Benjamin Libet has done some really interesting experiments. Let us look at a few of these experiments. So the thing is, when you stimulate a person directly in the cortex, right? We know that the person can feel some experience, right? So here there's certain conditions to that stimulus, the electrical stimulus that you give to the cortex. That is, you have to give that current to minimum duration, and the current intensity must cross some threshold. Otherwise, you won't feel, the person doesn't feel anything. And when you're giving it as a pulse time, the frequency also should be sufficiently high. Okay, so now you can define a certain quantity called liminal 1, which is, if I present this current for 0.5 seconds, what is the minimum intensity that I have to present, I have to give for the subject to be conscious of it, right? So even when you give that kind of a stimulus which is sufficiently strong, which is greater than threshold, it turns out that you have to give it for at least 500 milliseconds, that is half a second, for the subject to feel it. Otherwise, it is not sensed at all. Why is there that delay? Why do you need such a long stimulation? Because half a second is a very long simulation. because neurons operate in the time scale of milliseconds. So why do you need 500 milliseconds for subject to become aware? And this question is even more interesting because if I give a stimulus from the periphery, like I touch the skin, touch the person's finger, that information reaches the cortex in 20 milliseconds, right? If that is the case, then why do you have to stimulate the cortex for 500 milliseconds for the person to become aware? So let us look at this kind of a data. Let us define some kind of a time events. The first one, TC object or objective word, that is time at which the cortex stimulus is given in the objective world, because the stimulus is given by some kind of experimentalist to the subject, right? And that happens in the objective world. Then time C sub, right, is the time at which the cortical stimulus is felt, and that feeling happens in the subjective world, because that's something only the subject knows. The experimenter doesn't know. The subject reports back and says, "Oh, I have felt something." So you have to just believe that person. And so that's purely subjective. That happens at TC sub. Okay, so TC obj is here at say time 0. The TC sub happens after 500 milliseconds or about half a second. This is what happens in case of direct cortical stimulation. But when you give peripheral stimulation, the T obj S, the skin stimulus given the objective world, that is this event. T says subject time at which skin stimulus is felt in the subjective world, that is here. This interval is only 20 milliseconds. So whereas if it always takes 500 milliseconds to become to get conscious perception of the stimulus, right? Why does it take so little time when you stimulate the peripheries? Whereas why does it take so long when you stimulate directly the brain? Okay, what is going on? So one tricky part of this kind of experiments, which is also this a subject of a lot of debate and controversy, is this question of subjective timing, because you see that the TC sub is subjective time, TS sub is a subjective time. So if you are measuring the time duration of an objective process, that is somewhat well defined. But how do you define when exactly you felt something? It's a tricky question. Also in the experiment, what they do is they have this kind of a dial on which there is a moving dot going round and round. So how do you define the subjective times of your thoughts or your feelings? So what subjects are asked to do is, when you feel, at that moment, remember where this dot was. Okay, and they'll say, oh, it was at position 10, it was at position 40 or whatever. Based on that, they kind of make out what the time was. And this procedure is fraught with controversies, but anyway, that was what they've done. So what Libet has given as an explanation to this process is that there is a subjective referral backwards in time, because brain knows that right, the cortex needs such a long time to become aware, whereas the time taken by the signal is only 20 milliseconds, right? So in order to time the signals properly, brain kind of artificially deducts time and reverse it backwards, right, subjectively. So, and normally the signals come from the world, from the skin directly. Signals never come directly to the cortex. That is happening now because experimentalists have figured out how to open the brain and give stimuli directly to the cortex. Otherwise, normally the natural condition signals comes from the world and flows to the sensory channels normally. So, so he says, the brain has learned to do this kind of a subjective referral backwards. So, the cortical activity due to sensory stimulus must persist for a minimum duration to produce a conscious sensation, right? Which is called neuronal adequacy. Only when there are adequate conditions occurring in the brain, that is when the subject has a subjective experience. And that's called neuronal adequacy. Once the adequacy is achieved, subjective timing of the experience is referred backwards. And so this is his theory. Now, that is some observations on the sensory side, on the side of sensory perception. What about on the motor side, or where there is willed action? So here also people found some really strange aberrations, right? Because when it comes to willed action, what do we normally think? Let's say I want to have some tea, or just maybe I want to lift my hand for no reason. So what do you think is the sequence of events? I get the intention to lift my hand, and that intention causes some kind of an activity in the brain, and hopefully in the motor cortex of the brain. Like magic, somehow, let us say the activity appears in the motor cortex. The activity then flows via specific motor nerves and all that to the hand, and my hand moves. This is what I would imagine as what's happening, right? But intrinsically, interestingly, that's not quite what happens. So let us see what happens. So one problem is this, right? When you talk about motor function, a simple way to describe it is as simply, brain is receiving sensory input from the world and producing motor response. But it's not as simple as that, because between sensory input and motor output, right, there is some kind of a filter, because everything that somebody asks you to do something, you may or may not do that. So you are free to reject or accept that kind of a option, the choice. So the problem is not everybody has this as capability. So there's some disease conditions where people are not able to make this kind of a conscious choice and reject or accept certain possibilities for action. Okay, so for example, this patients that were studied by this doctor called Francois Hermite, right? These people were slaves to sensory world. That is, if you show them a toothbrush, they'll pick it up immediately and start brushing themselves. If you show them a comb, they'll pick it up and then start combing themselves. If you show them a bed, they'll go ahead and jump on the bed and they'll try to sleep. So every object has an intention, as a kind of a purpose, and it is meant to be used in some fashion. But that doesn't mean that if you have the object in front of you, start using it like that, right? You have the power to kind of respond to the object or not respond to the object. And that's what makes you a conscious self, right? But these people don't have that ability to control. They just have to respond to it and do some kind of default thing. So this condition is called environment dependency syndrome. They are such slaves of the environment. There's no conscious. It's as though there's no conscious self that decides on to do or not to do something. In this case, usually the damage is in the prefrontal cortex. So, right. So in the experiments by Gray Walter, right, tell you something very funny about how this build action gets translated into motor cortex. So this guy has taken certain subjects in whom there was electrodes implanted in their supplementary motor area. So SMA is the highest center in the motor hierarchy. So if you activate SMA, information goes to the primary motor cortex, and from there to the spinal cord, and then finally it activates the muscles, and you have movement. So there's an electrode implanted in the SMA, and that electrode directly connects to certain slides, which you can see on the screen, and you can activate the electrode by passing current artificially. And the subject is asked to press a button, and he was told that if you press the button, the slides will move, the slides will change. So he was asked, like, whenever you feel like changing the slides, you press the button. That's what he was asked. So problem is, whenever the current is passed into SMA, that seems to create some kind of intention to press the button. This guy will try to press the button, but problem is that signal would have already gone directly from SMA to the slide changer. So even before he presses the button, the slides would move, right? And normally he would think that after pressing the button, after a small delay, the slides will move. But just when he's about to press the button, slides will move, as though the slides are able to read his mind, right? Read his thoughts, which can be quite shocking. So what we will normally think is that will comes first, and will produces certain brain activity, and that brain activity then produces some actual physical motor movement. But that's not what happens. Let us think of this sequence. So your natural expectation is like this: build action first, W, then motor cortical activity, that is C, and then actual movement, that is M. But the events that is seen. So Blibet also has done similar experiments. events that is seen in these experiments is motor cortical activity happens first. That later creates a sense of will in the subject's mind, and after that, the actual movement takes place. So, which is quite scary because normally we think that we are in charge, our conscious self is in charge, and because our conscious self had thought of this intention, right, had this intention arising in itself to press the button, let us say, right, that's what creates a motor activity, and that's then in turn, right, creates muscle activity which will produce the movement. But that's not how it is happening. Here, ultimately, they activated the cortex first. That created a subject sense of right intention or will, and then movement occurred. So, will seems to be something that is secondary. It's not primary thing. Primary causes brain's activity. Lowers our stature as the self and I and ego and all those. So, to summarize the situation, brain initiates action all by itself and is courteous enough to inform us by the way about the proceedings that were initiated right under the nose of the conscious self. Conscious self is sitting there like a figurehead, right? Brain does everything, it just informs you. By the by, I am going to move your hand to press the button. I just want you to be aware of it, right? You don't have to give me a permission. I'm already halfway through doing it. I'm just informing you. That's what brain seems to be telling the conscious self, which is quite shocking. So in short, the question of consciousness is to figure out the relationship between two domains. So the Nobel laureate Gerald Edelman calls this domain C and C prime. C is the world of conscious experience and its contents, your thoughts and feelings and the whole rich colorful world of the inner subjective experiences. Then C prime is objective world of stimuli. What is the connection between these two? Which stimuli from the objective world produces which thought or which experience in your subjective world? What is the mapping? It's a very hard problem because the mapping is not one-to-one. It's quite variable, varies from person to person, time to time, and so on. And one more thing about consciousness is it involves brain in a global fashion, because in the experiment done by Dahan and his co-workers, they presented words visually and very briefly, and after that they were masked. So we have seen this kind of a masking in emotion studies, right? That means the words were present too briefly, like if you present them for let's say 10 milliseconds and close them, you won't remember any, you won't have any conscious memory of it, but you can show that the information has gone to your visual cortex, right? But so you will see the visual cortical activity in your fMRI also. But if you ask the subject, they will say, I haven't seen anything, which means activity visual cortex alone is not enough. But if you present it for sufficiently long time, it should be typically about 100 plus milliseconds, then subjects will say that they are conscious of it. And when that happens, you will see activity spreading not only far beyond vision in parietal and frontal areas. So even to understand vision, they have to include big part of the brain. So brain acts as a whole when it comes to conscious activity. So seeing this kind of experiments, Bernard Baars proposed what is called the global workspace theory. That is, there is a global workspace in the brain, and there is a lot of synchronized activity over distant parts of the brain supporting conscious activity. Right? If there's no need for consciousness, there's no need for this kind of a global synchronization. People also have proposed physical theories of consciousness, like for example, Susan Pocket and John Joe McFadden propose that the EM field generated by the neural activity is substrate for consciousness. Right, and synchronous activity of the EM field is stronger in case of more conscious states, and this is also consistent with proposals that gamma range is related to consciousness. So it will be interesting if we can create a separate set of Maxwell equations for the brain, right? And maybe a physics-based theory of mind and consciousness might even modify our theories of physics or the way we deal with the real world, because there's something called a subjective time. We can have aberrations of subjective time, even in very delicately designed experiments, or even certain disease conditions like schizophrenia, for example. Now, So right now we are saying that this is just psychological time and this is real time. But there was a time when people thought that there is something called animal electricity and there is real electricity, right? That people thought the electricity that is seen in biological tissue is different from electricity seen in the in electricity in the copper wires. But later on, people found out it's all the same electricity. So similarly, maybe there will be a time when there will be unified physical theory that explains both the phenomena outside in the world and all the phenomena inside in the consciousness. Okay, so with that, let me stop. May the consciousness be with you. So I think I'm done with the topic and I'm done with the course. We just have actually one more lecture slot because the exam is on next Friday, I believe, last quiz. Now I want to make an offer. I very strongly believe in some method for motivation and leadership, some training of motivation and leadership, because it will improve the quality of life. Right? In my lab, we do a lot of this stuff. We watch videos on leadership and motivation, and my students find it very interesting and useful and keep them motivated to do better in research. And with all this COVID thing going on, I'm sure things are quite depressing and at home, and you guys are doing a fantastic job, like trying to cope with all this and still doing well in your academics. But if you're interested, we can spend next one class, like next Wednesday. I can give a talk on leadership and motivation, or we can watch some video together and just talk about it. Right? If you're interested, let me know, and we can spend the next hour, that is in Wednesday class, like that. So that class is still available to us. Otherwise, we can just say, Alvida today, and we can wrap up. So please let me know, or you can send a mail to me or the TA.
Thank you, sir.
Hello. Okay, thank you.